Let's just start off with electrical systems test 3. When we're through with this, I'm going to show you some stuff on the overhead that covers some of this same stuff, and I think you're probably going to enjoy that. Hello, come on, there we go. A starter is a high torque electric motor that converts electrical energy from battery into mechanical energy to crank the engine. These are true-false questions, and I need somebody to sing out and say, is that true or is that false? That's true. A lot of the starters nowadays have got, as a matter of fact, just about all of them that they put on newer model cars nowadays have got a planetary gear set in them. And that planetary gear set takes a very small, this permanent magnet motor, takes the torque from it, and that motor spins really, really fast. And the planetary gear set slows it down, gives it more power, and enables them to make a starter that's smaller that will do a lot more work. It's smaller, it's lighter, and it'll do more work than the old starters. That being said, you can buy one of the old starters that's got field coils and all that stuff, like the one you see on this board over here, for something like $40. Like if you wanted to buy one for that 350 engine we got out there, 40 bucks for a starter. These are usually $100 to $200. A no-load test on some starters can be made even after a starter's been removed from the vehicle. What do we call that? They call it a no-load test. What do we call it? You guys, some of you guys have done it. Bench test, and everybody knows how to do that. You better know how to bench test a starter. You pull the starter off and you hook the positive battery terminals to the big post, and you hook the ground to the body of the starter, and then you short power to the little terminal, and it should kick in and you should see it work. Now, I think, Amber, you did a starter on a Nissan Maxima. You remember that? Yeah, it seemed to be starting okay on the car, but they were bringing it in. They brought it in here because they said the starter was suspect. And we started it up, we pulled it in, and when we put it on the bench and bench tested it, it worked on the car, but when we put it on the bench, it was just, it barely would turn, or it didn't do anything. I can't remember what we did. We bench tested it and verified the starter was the problem. So, battery is the source of electric current to operate the starter. Is that true or is that false?
Yes.
It is, isn't it? Where does it come from if it don't come from the battery? Where else can it come from? The starting system converts electrical energy from the solenoid into mechanical energy from the starter. Ooh, that's sort of a screwball way of saying that. That's false.
Isn't it backwards?
That's number 4. Yeah. I mean, it converts, converts mechanical energy. The solenoid actually, that whole premise is screwed up. What the solenoid does is it basically pulls a movable core back that slaps a copper washer, and it makes the contact between the battery terminal and the one going down into the starter. That spins the starter, but at the same time it's hooked to a yoke that throws the starter drive into the flywheel, and it won't even start spinning until the starter drive is already in there. Now on that Cadillac, when it first came in here, that 71 Cadillac that we work on every now and then, it had popped a tooth off of the flywheel. Who was here and saw that? It would pop a tooth off the flywheel, and it wasn't, jittering on top of the teeth. It would shear a tooth off when it went in there, and then it needed a flywheel. How many of you would like to experience pulling the transmission out of an Eldorado Cadillac, that vintage? That was no fun. Bobby Lundy did it 2 times. Well, we put the starter on that one, didn't go on there like a regular Chevrolet starter. It went on there with holes like this. The engine was a 76 model, the transaxle was a 71 model, and while they bolted together, there was some variability that made the spacing wrong. And whenever that starter would go in, the teeth on that flywheel they weren't chamfered or anything. And the starter would kick in so hard that the end of the starter tooth would hit the flywheel tooth and just knock it off. And then there was no tooth there, and the starter would just go, yeah. And you could turn the flywheel a little bit, and the car would start until it knocked another tooth off. And so what we wound up having to do ultimately, we got another flywheel, and I got the high-speed cutter, and I chamfered every tooth opposite of the chamfer on the starter gear. And what I mean, a chamfer is a bevel on the gear, so that whenever that starter kicked in, it wouldn't hit the end of that gear. It would go past it and go in and all that. And also we egged one of the holes and brought that thing in so it had a nice positive engagement, and we stopped that problem. There's been no issues with that thing since then, but it was a bear to start with. All right, a voltage drop test is performed while cranking the engine, if you're talking about starters. Is that true or is that false? True. Can you do yeah, you cannot do a voltage drop test unless current is flowing. There has to be some current flowing before a voltage drop test. You might even, the ones of you that have read a little ways into this parasitic drains thing I gave you, might even see where that guy's talking about taking a meter and doing a voltage drop test across each fuse. And when you come to one that's got a fairly high voltage drop that's not supposed to have any current flowing across it, that'll point you to the source of it by doing that. And that works pretty good. That's a really good article. Do not neglect to read that. I gave you one too. One of these, you know. So anyway, rebuilding a starter is a very common service practice. When I was in the field, yes, we used to put starter drives, we'd put bushings, we'd put brushes, we did all kinds of stuff. Even as late as the 90s. Well, there's still a place in Enterprise where you can take starters and have them rebuilt and stuff. All right, when is it beneficial to build a starter instead of replacing it? That's a good answer. The starter on my John Deere lawnmower, my John Deere lawnmower's got a Kawasaki engine in it, and the starter on that thing cost $600 for that lawnmower. It's a little lawnmower starter, and it was starting to give trouble. You know, brushes were getting to where they were worn out, and also I says, how much would a starter cost? I figured it probably cost $125, something like that. And they said $650 or something. I said, okay, well, give me some brushes for it, because there ain't typically nothing wrong with the armature or the permanent magnets in it. You know, may need a starter drive, but if you can get parts for a starter, if building it's less expensive. My dad had a Ford Tempo that my wife put 28,000 miles on it from the time it was a new car till we sold it to him, and it's 8 years old. And a starter is going to wear out quicker on a low mileage car than it is a high mileage car, if the car is used for a lot of short trips, because it gets started a lot, but it don't get driven a lot. You understand what I'm saying? Like, my wife didn't go very far when she went anywhere, but she started it more per mile, you know, over 8 years, even though it didn't have very many miles on it. It had been started a lot of time. Well, he says the starter's giving trouble on this car, and I said, well, if you'll go down to the shop, wherever it was in Dothan, I said, get you some brushes. But well, my dad was a mechanic, you know, most of his life, and so he took the starter off the car and put brushes in it for $15. So it'd have been $150 for a starter. That's the whole deal. That's when you'd rebuild it. You don't see people rebuild starters much anymore, though. We just pop one on there. That's right. Alternators can be rebuilt, and the cool thing about an alternator shop is they got a lot of parts laying around, and if they build it and they test it and it doesn't work, they just say, well, there must be something wrong with this stator that we can't see, and then they'll pop another one in there. But if you're working and all you have is your parts laying out there, and you bought some and you happen to get a bad part, I've actually worked on alternators and fixed them when I was at the Ford place. Like on ambulances, when they have a great big Lease Neville alternator, like I had a bad voltage regulator or something, I'd pull it off and tear it down, put, you know, rectifier bridges in them and stuff like that. But number 6 is basically false, because most of the time they just pop one on there. Low current flows to the starter only when the ignition switch is in the start position. Now, that's false. There's always current there, you know. But that's a kind of a peculiar question, and I don't even think I would have written it if I was going to write the question. The starter stops cranking the engine when the ignition switch returns to the run position. That's true. There's an overrunning clutch in the starter drive that prevents the engine from driving a starter. How many of you guys have done any work at all on a Briggs & Stratton lawnmower engine? All right, that little thing, it's your little square part that your pull cord is hooked to. You ever had one of those that you took apart and they got them little balls and stuff down in there? That's what that is. It's an overrunning clutch. It basically, when you pull it, it grabs one way, but when the engine's running, the little balls bounce around in there, but it's not going to drive the little pulley that you pull it through. These are the same weight. And what you got in that overrunning clutch, I had one of them starter drives in here that was, you know, that I had torn apart one time. But it's like an overrunning clutch in a transmission. It's basically got some little ramps and with rollers in them. And whenever the it's turning one way, those ramps roll up there and get pinched and cause it to turn. But when it keeps on going, have you ever started your car or tried to start the car whenever it was already started and heard that noise it makes? And what that does is it's that overrunning clutch is just going crazy because of it's in the flywheel, but the flywheel's spinning the overrunning clutch. They don't want it spinning the guts of the starter, okay? That's a bad thing. Let's see, the overrunning clutch prevents it. Yeah, that's true. Gear reduction increases starter torque by decreasing gear ratio. That's a bad way of saying that, so that's false. But what I was saying earlier, basically the gear ratio is changed so that fast spinning motor is going to have more power. An electrical device in the starting system, it opens or closes a circuit in response to a voltage signal that's going to be a starter relay. The starter relay is typically, well, let me back up and say this. Ever since about the mid-2000s, there are a lot of vehicles that when you turn the ignition switch to the start position, you are not directly engaging the solenoid. You are requesting that the engine controller or some other module energize the solenoid, and that's done with a relay. And so, like if you've ever driven something like a mid-2000s Buick or something, you might notice that if you turn the key, it will, even though if you turn it just briefly, it spins the starter until the engine fires up automatically. I mean, basically you just tap the key and it keeps on spinning it. It doesn't seem to correlate with your movement of the key sometimes. Even though you've let it off, like on most of the vehicles that you were used to, and we let off, but you let off now, it'll still keep spinning until it fires up. When you're pulling a starter off and putting it back on, and everybody in here's got a worksheet where you're supposed to do that, and some of you already done it. Make sure that you don't, when you're fooling with these wires up here around the solenoid, you get frustrated and you put those lugs on there and you turn it and things move around, and occasionally you'll see somebody that has one that they bend over here so that the trigger terminal, the solenoid wire, is touching the big battery cable wire, and hook the battery cable back up and you get the starter steady spinning and it won't stop. You know what I mean? I had one guy out here that somehow managed to do it on that green GMC, and this was years and years ago, and he went to start it, and when he let off the ignition, it was still spinning. What do you do?
Disconnect the battery.
And you need to kind of be quick about it. You know what I mean? I mean, don't just let it keep spinning, because that's not good for anything. So he was just standing out there. Keep your head when this stuff's going on. Don't lose your train of thought, because all he was doing was standing out there holding his hands up in the air with the key, and I'm showing everybody that he had the key and the engine was still spinning over, and he had a silly grin on his face. And I said, get over there and unhook the battery. What are you doing? And just holding your hands up in the air. I mean, he just noticed that it was spinning over, and he was sort of, he went blank. He didn't know what to do. But the smartest thing you can do is go pull a battery cable off. It may take you a minute or two to do it, but get to work on it,
I started hanging up in a Ford truck, and it spun it apart. Like it was one of them old starter lines, and threw the BBs and stuff through the little dust cover on the bottom of the transmission.
It can cause some pretty serious issues. Now here's another thing. Some of the Power Stroke diesels, even the earlier ones, had a big long aluminum reduction drive starter on them that was like $700, and it was made by Mitsubishi or somebody. I don't know who made that starter. It was a Japanese made starter, and I've seen one of them like that here. As a matter of fact, I think I posted something on my Facebook page about that, or my Technical Rider page. But there was I noticed that I'd get under that truck, I'd just lay on the ground under it in the parking lot out there, and I'd look at the starter, whatever they say. It wouldn't start. It just turned the key and nothing happens. Batteries are good and strong. You can't jump it off. And I'd get under there, and on the back of the starter, on those starters like that, you got your big thing in the middle, and you got this, and you've got the screws that hold the starter together, but you'll see some smaller Phillips head screws right here. Now those Phillips head screws provide a ground to the brushes on the starter. And what I've actually seen happen, I'd look under there and I would see scorch marks like it had been arcing around one of those. And all I would have to do to fix that starter was take these screws out one at a time and polish up that metal and polish the screw and put them back in there. And that truck would drive out of there starting just fine. And it would have been a travesty to put a $700 starter on a truck that just needed those screws cleaned. There was a girl that came in here, I don't even know if any of y'all was here at the time or not. She said, we just put a starter on my Sebring or whatever it was she was driving, it some kind of a Chrysler. And she says, because we were having to hit the starter to get it to start. And so we put a starter on there and we have to hit this one to get it to start too. And so I got under there and I saw this. I saw arcing around one of those screws. I even took a picture of it. I got it somewhere. And I cleaned all that up and put it back together and her problem was gone. But a lot of the times, the little screws like that provide, they get a ground through the housing. If those aren't tight, you don't have issues like that. That's just a little something you're not going to see in any textbook that I've ever seen. I mean, you kind of, stumble across stuff like that you might remember. Also, it's really important to make sure that all of the copper lugs and nuts and everything are really clean and snug. Be careful when you're tightening the big wire or any of them on a solenoid, because that solenoid has got that phenolic material that's really brittle. And if you ain't really careful, you can get a brand new starter from the parts house. And if you're doing something kind of destructive, like using an air ratchet to tighten the screw, or if you get a little bit over aggressive, you can break that darn thing. And do you think the parts store is going to give you another starter if you broke the solenoid phenolic? Heck no. I mean, somebody had to spend some money on that deal. And I tell you something else. Buying a solenoid is sometimes almost as expensive as buying a starter nowadays. You may pay $110 for a solenoid and the starter's only $122. So the little solenoids are kind of expensive. In a voltage drop test, normal voltage drop should be what? What should it be?
Less than half a volt.
Less than half a volt. Half a volt on the positive, 1/10 of a volt on the negative. That's always been the rule of thumb. I learned that in Jacksonville, Florida at Mazda Electrical School long years ago. A basic starting system complaint is A, the engine does not crank. How many times have you heard people say my car won't crank, but you hear them spinning it over? That means cranks normally but won't start. You got to have semantics down pat. The engine cranks slowly but does not start. The starter operates but does not crank the engine. All of the above. That's 14's D. It can be any of those. The pinion gear must rotate 15 times to rotate the ring gear once. If the starter operates at 3,000 RPM, it will crank the engine at what? Somebody need a laugh line? It's going to be, you know how I would answer that question? I remember that every time I've ever seen the starting RPM when I'm looking at the scan tool, it's always about 200. About 200 RPM. Now, on a hybrid vehicle, the hybrid motor in there that starts it will spin the engine about 1100 RPM to start it. And it sounds like it's running in a situation like that. Now then, that's all the questions you had on that test, wasn't it?
What's 12?
Huh?
12.
Oh, the voltage drop. Wait a minute. Number 12 number is B. That's the cranking voltage current. Well, that test measures battery voltage and current during engine cranking. Once again, your battery voltage while you're cranking the engine should not go, if you're testing the battery that way, it shouldn't go below 9.6 volts spinning the starter 15 seconds. Now let's jump into this right quick. I think we can blow through this one pretty quick. Part numbers for a generator and a regulator are usually the same. We're talking about charging systems now. That's false. You're not going to have the same part number for a generator and a regulator. That's silly. In order for the charging system to supply all the current needed for the vehicle operation, lights and accessories, the engine has to be running. That's a no-brainer. The engine supplies the mechanical energy to drive the generator. Now, years ago, a generator looked a lot like a starter and had a pulley and a fan on it. And this was, I'm talking 50s. Early in the 1960s, they started putting alternators on there, and they made alternating current that was rectified and basically turned into DC current when it came out of it. But now the J1930 regulation came out, and I don't know if that's the reason for it, but a lot of your shop manuals will call the alternator a generator. my contention was if the PCM controls the field, they call it a generator. If it's standalone, they call it an alternator. But there's some confusion about where that came from or why they call it that. I've had some people say, no, J1930 didn't do that, but it seemed to happen about that time, so I don't know. One way or another, just because you see generator in the shop manual, don't get confused. I remember I wrote an article about alternators for one edition of Motor Age magazine, and I was talking to Vistion because they rebuild alternators. They read my article and they were, they want me to tweak it and say different things, and I said, well, everybody calls it a generator now, and the people at Vistion, the engineer I was talking to, he says, I don't care what they call them, it's an alternator. So I used the word alternator all the way through the article. He was paying the bill. The only excuse me, wait a minute. Let me come down here. The crankshaft burns approximately 3 times as fast as the generator rotor. That's false. The smaller pulley is going to be the one that's spinning faster, right? How big is the pulley on the crankshaft? It's usually about this big around. The one on the alternator is really little, unless it's on a Mitsubishi, and sometimes it'll have a pulley like that big on a Mitsubishi alternator, which is peculiar, I thought.
Skip 2 and 3.
The engine supplies mechanical energy to drive the generator.
True.
In order for the charging system to supply all the current needed for, the engine's got to be running, that's true. One disadvantage, wait a minute, a generator works on the principle of electromagnetic induction, is that true? When you've got magnetism sweeping across windings that are wrapped around a core, you're basically going to be creating energy, right? And it works really, really well. That's true. One disadvantage of an indicator light is that it's hard to read. True or false? Is everybody asleep? Is it hard to read an indicator light?
False.
Is that a digital signal or an analog one?
Analog.
No, it's digital. It's either on or off. Just like the light switch on the wall, it's digital. Either on or off, 1 or 0, right? Poor connections in a generator are a common cause of charging system failure. That's true. I used to see the stator windings where they were tied together, and some of the Ford alternators would be all scorched and burned and it wouldn't be putting out. And I would take those alternators apart and I would polish all of that stuff up and I would solder it and I'd put it back together. And customers tend to like it whenever they leave and their bill's like $30 instead of $300. You know what I mean? And that's why they would come back and say, I want him to work on my car because it doesn't usually cost much. One lady came in there one day. She says, my speedometer needle's bouncing all over the place. And I said, well, we typically replace the speedometer for that, and it's like $500. She goes, why do I have to pay $500 every time for something that's like this? And I said, well, I'll tell you what, I can take that speedometer apart and I think I can fix it, but there's no guarantee and I don't want to hear any whining if it don't work. And she says, fine, whatever you can do to save me money, I will. And so I took it apart, and where that little needle was going down in that little spinning drum, I put a little drop of oil down in there, and it never gave any more trouble, and she got a $25 bill. But after a while, those speedometers got to where they weren't available anymore. What do you do? Anyway, I fixed a bunch of them like that. Okay, let me see. The only complete test, wait a minute, can the generator be only be accessed from under the engine compartment?
No.
Well, that's false, because, they're in different places, The only complete test of a generator is a current output test. Yep. I would say the only complete test includes the current output test, but that should be true. Checking and adjusting the drive belt tension is an important part of charging system service. What about that? That's true, but most of these things have spring-loaded tensioners now, right? Number 11, the generator component most likely to fail is the what?
Brushes.
The brushes. The brushes are the most likely thing that are going to fail because they're the hard-working component there. They're always dragging across that commutator. And a commutator is like this little copper strip right here. They got those on the motor. I say a commutator. It's not really a commutator. They're basically little strips that don't have segments on an alternator, and they basically keep the thing charged up, but they're sliding on it one way or another. Incidentally, when Vistion rebuilds one, they measure the diameter of those slip rings so that they'll make sure that they haven't worn down. And a lot of the other manufacturers don't do that. They just throw brushes in them. A possible cause for an undercharged battery and slow cranking is what?
Freaking short trips.
Well, what else y'all think? Frequent short trip driving sounds good to me, doesn't it? Because it doesn't have time to build back up. that's not as much of a problem on short trip driving as sludging up the engine. What we used to do is we would find at the dealership, we would have some that would say when they're driving around slow, they would have battery go dead. And that was always sort of messy. But what we would do is take the charging system tester and put on it. And just like we were going to check the charging system, and then we would turn on the guy's radio, we'd turn on his blower motor, we'd turn on his wipers, we'd turn on his headlights, we'd turn on every accessory he's probably using while he's cruising. And if we see negative amps, we know that that's going to be killing him, right? If you're cruising around town, we're going really slow with all your AC with the blower on high and all that kind of stuff, and the alternator's not putting out enough at those low speeds to keep that thing up, your battery's going to die. And the only thing you could do that would help with that is maybe put a smaller pulley on the alternator. But, you know, whatever. The blank is not a major component inside the generator. Resistor. That's number 13. He's got that right, doesn't he? Tests made to determine whether the charging system's operating normally include A, charging voltage, B, generator relay, C, voltage peak test, all the above.
All the above.
If you load it a little bit, pull that voltage down, the regulator will kick it up to where it's doing the right, you know, it's charging up right. In other words, it's going to actually try to hit a target voltage, and if you lower the voltage that it's seeing, you're going to see more amps. That's what that charging system test is about. You got a worksheet on that. Charging system includes a generator, system wiring, voltage regulator. That's a no-brainer. Today's charging systems use a blank generator. AC generator. Now, I'm not going to fool with these matching things because I think they're pretty much a waste of our time. And so I want to, you know, show you this stuff I got up here on the screen now.